I'm going to share with I'm going to share with you my slideshow, and let me get started here. Takes me a little second to get everything going. And hopefully you can all see this now. This is my opening slide. And I've got a picture basically of my human hive, which are my family. These are my family of beekeepers. That's me over here. And here are some of my friends that I do a lot of beekeeping with. Here's a family, and I wonder who this is. This is Mr. Throop-Voors' son and his wife. They came out, and that's when we had the great idea to share my love with all of you, my love of the honeybees. And over here we have another group of honeybee keepers, and we're making frames and things, but we are all ages. Some of us are quite old and some of us are young. So let's get started with the beehive. So I wanted to show you my human hive, and now we're going to talk about the beehive. What are they all about? So I'm going to be starting with two different kinds of hives. One of them is the usual typical hive that I know a lot of you know about. Remember, this is the home. This is the house of the honeybees. And right here, it was a very hot day in the springtime, and some of them are out here on the front porch cooling off. Isn't that what you would do in your house if it got a little hot and you didn't have AC? You'd probably go sit out on the front porch. They also could be getting ready to swarm because that's what they do in the springtime. Over in this video, this is a different kind of hive. This is a top bar hive. That's the kind of hive I have. It's a little bit different. These are the kinds of hives that they have in Africa. They're like log hives. So remember, all bees need some kind of a house to live in because they live all year long. They are one of the only bees that need to live all year. They do not hibernate like many insects. So sometimes they live in trees, in hollow logs, and sometimes in old buildings. Maybe one thing you can discuss as a class, did any of you ever have bees come into your house? Let's talk now about what happens inside the hive. You know, you see it from the outside, but what are the bees doing all day and really all night? So let's start with this. This is a worker bee, a female, and she is making wax. Her body, in her abdomen, she has wax glands. The wax glands produce wax just like your glands. You have glands too. You have sweat glands, as an example, and your sweat glands produce sweat to help you cool off. Well, the wax is used by the honeybees to make their comb. This is called comb. And here you see the honeybees, which are taking the wax off of the abdomen of their other beekeeper bees, and they're making a wall and they're making cells. Each one of these cells has 6 sides, so it's a hexagonal shape. And the hex shape is very important in the bee world. So here you look at the honeybees, the worker bees, are feeding the babies, and they're also making wax covers for all the cells that have larvae in them. And here you see the honeybees, they're putting their nectar to make honey with. And you can really see the hexagonal cells here. In this picture, you can see the different stages of the honeybee. They start out with the eggs, and then they go to the larva, and then the pupa, and then the adult. That is actually the life cycle of all insects, and it's really important for you to learn the life cycle of the insects for many, many reasons. Larva like this is the same as a caterpillar for a butterfly. And they are so important as a food resource for many, many animals. I understand that you have done a little bit with food chains. Well, food chains many times begin with plants, but then they go right into the caterpillar stage, which eats the leaves. Let's go over here now to look at these adult worker bees. They are feeding the larva. You can see this bee has its head in the cell, and they are taking bee bread and putting it inside it to the cell. And these larvae are just maturing every day, getting bigger and bigger and bigger. You can see this one, barely see it. It's maybe a 1 or 2 day old larva, and these are like 7 and 8 days. So everything is moving along nicely. Let's keep going. What else is happening in the hive? Well, there's one queen in the hive, and yes, she's very important, but really, everybody in the hive is important. Just like in the human hive, all of us are important. You guys are really important. We have our hope in you that you will help us save the honeybees. So let me tell you what is happening here. Here's the queen. She has a very long abdomen because there's a lot of eggs in here. And here are the worker bees. They're all females, and they are feeding her. They are cleaning her. They also are touching her. Why are they touching her? Because their antennas, you see how they are touching her body? They are getting the smell, the pheromones of the honey, the queen bee, because they have to give that pheromone to all these bees over here. Because when they come back to the hive, if they don't have the smell of the queen, they won't let them in because they will think it's a different hive trying to come in and rob them of their honey. Let's take a look now at a baby queen bee coming out. She has a different kind of cell. Isn't it just beautiful? She actually has to use her mandibles to cut a little edge like this so that the lid comes up and she can come out. Here she is. She's pushing herself out. Sometimes she actually needs help from the worker bees to do this. Look how hairy she is. Honeybees are one of the hairiest animals, and we'll see why that hair is so important. So after a year or two, the old queen, she leaves the hive, and this new queen will become the queen of the hive. Now, a beekeeper, this is very important. I'm a beekeeper, and I look for a good queen with good genetics that will help the next generation with traits to fight the changes in the environment, like climate change. I just want to mention one thing about what's happening in Florida right now and what happened 2 weeks ago in Georgia and North Carolina. These states have a lot of beehives. A lot of our honey comes from these states. So they are going to have a very, very difficult time because many of their beehives were killed in the flood. So it makes me quite sad, but that is what happens. But bees do have ways of evolving so that they can fight this climate change and become adapted to the new conditions. So if we look at the next slide, these are jobs that the honeybees have to do outside the hive. The first one is the forager bee. She's an older adult bee, and she has um, a bag here that she fills with pollen. But look at all the pollen on her hair, on her body. She takes that all back to the hive. This is from a flower that she has gone to pollinate with. Now, she doesn't know she's pollinating. She's going here to collect pollen to feed the hive. So she'll go back and they'll take off all this pollen so that she can go out again. Now, this is a stinger. Excuse me. This is a stinger. And on the edge of this stinger, this is what goes into your body if you get stung. There's a little hook, like a fish hook, and it gets stuck in your body. And then this is a venom bag. So in this bag is a lot of venom, and it continues to pulsate as it's in your body or in any enemy that comes to rob the hive. And that keeps pulsing and pushing venom down into the point. So that's why you get a swollen area. And this is a guard bee. Now, I know she doesn't look that fierce, but believe me, she is fierce. A sting can do a lot of damage. I want you to know that in Africa, they often use beehives to have around their gardens so that the elephants won't come and take the food in the garden. Why would an elephant be afraid of a little tiny bee? Because they have big ears and they're sensitive. And these girls can do an incredible stinging job on that elephant. Okay, let's go to the next slide. You know, this is a picture of a wasp over here. Now, a wasp is a carnivore. Carnivores eat meat. And this is the larva, probably of a butterfly. Watch it gobble down. It's got its four legs and it's picked up a piece of that um, caterpillar and it's just chowing down on it. So a wasp is a carnivore. They eat other insects, they eat eggs, they eat larvae, and sometimes they even eat dead insects, which is a very important part of the food chain because they can also be decomposers. Let's take a look now at the honeybee. The honeybee is not a carnivore. She is an herbivore, and she eats fruits and nectar from flowers, but that's in my garden, and they are just chowing down, sucking up the juices of this beautiful, delicious plum. Now, bees and butterflies are herbivores. Dragonflies and wasps are carnivores. They eat bees. I know, I love the dragonflies too, but that's the thing about nature. Frequently, animals, they have to eat other animals. That's their diet. That's what they have to do, and it's part of the balance of nature. Let's take a look at what happened 130 million years ago. You know, that's a long, long time ago. At that time, honeybees were carnivores because plants didn't have flowers the way they have now. Their flowers were nothing, and they didn't know they could eat flowers. So in order to start looking at pollen, their bodies had to change. They had to change their whole body and their behavior. One of the things that they had to do was get wax glands like this worker bee. They had to learn how to make the comb for inside the house. It's like in a house, you have to have furniture. They needed this to the comb to put their nectar in, and they needed the pollen for bee bread. And then they could put their eggs in there. This is all part of their house, but this was not part of their bodies 130 million years ago. Look how hairy this bee is. And here you can see the pollen bag on the worker bee. The other thing that they had to evolve or change to is a tongue that could suck up the nectar. So it's really an incredible way that the bee has changed over these millions of years. And the plants, they also had to change. 130 million years ago, plants didn't have flowers like this that were beautiful. They were really little just green things that no one could see. They looked like the leaves, and they were all wind pollinated. Well, you know, when the wind blows on the pollen, it just blows it everywhere. But plants need to be pollinated by the same kind of flower. So to be more effective, they need to have these honeybees come and take the pollen from this flower and put it on the same kind of flower. So pollination became very effective. And the competition between flowers became great. They started changing. They started having different colors and different ways of being. For instance, this is a squash plant, and I hope you all can go out in the springtime and look at this plant because it gives us, well, actually, pumpkins are right now in California are growing. That's in the squash family. And what happens is they have these incredible Male flowers are separated from female flowers. So the pumpkin is made down here underneath. Here's a squash fruit right down here. That's a female flower. But this is the pollen from a male flower. So the bees are attracted to the pollen, but eventually they find the female flower so they can fertilize the egg. So this separation of male flower from female flower is very important so that the pollen from one flower cannot go and pollinate itself. And in this flower, you can see how what they've evolved is to put the anthers, the pollen is stored in the anthers, and you can see how they have that anther sticking out, so the bees just can't miss it. But you know, these changes took millions of years. Changes in body parts and in behavior are called adaptations. And over time, this is called evolution. In the case of plants and bees, it is called co-evolution because they evolved together. They changed to see what would help them the most. In this particular slide, I want to talk a little bit about communication. You know, that's something we as human beings do all the time. We talk with each other, but sometimes it's confusing because our emotions get in there as well. Well, bees, they also have to communicate, and what they do is the waggle dance. The waggle dance is kind of a circle. But what they can tell the other bees is if they go in only one little circle, then the flowers are nearby. But if they do a figure eight, then it's a long distance away. If they go to the right first, then they know that it's to the right of their hive. If they go to the left first, they know it's to the left of their hive. A student of mine made this incredible drawing, and I just love it. She used the hex cell, the hexagonal cell, and she showed that these angles, which she drew with the protractor, and I hope you are all going to be able to use your protractor to do this. The bees go out of their hive. Here's their hive in the middle of the circle or the hexagon. They find out where is that sun when it comes up. Okay, and then they measure where the flowers, they fly out here, they find the flowers, and they say, oh, it's at 60 degrees away from the flower, away from the sun. So we have to fly in that direction to find the flowers. If it's 120, it's 60 plus 60 is 120. So then they would have to fly 120 degrees away from the sun. So let's keep going here. Once they have told all the bees where to go, they fly like an army out to the flowers to pollinate. Now, remember, honeybees, one thing that they love to do is to go to the same kind of flower. Why is that so important? And why is this so important for farming? And you have a lot of farms in Indiana, I know that. Well, if they go from one flower to the next flower and have the same kind of pollen, they are very effective pollinators. So the bees have become very dependent on this flower. Here you can see this bee just I don't know, just moving around into the pollen and getting it all over itself and stuffing that pollen into their knees. So they've become dependent on this pollen. The pollen is their protein, and the nectar is their carbohydrate. So let's take a look at the next slide. I want you to see the bees on this. This plant is in my garden. I just want you to take a look at what's going on. The bees are just all over it. They love this plant. And you know what's nice is it blooms right now in October. And very few plants here in California are blooming in October. Without this flower in October, the bees would not have food. It's their grocery store. So plants have become dependent on the bees to pollinate them. Over here, we have a different situation. It's in many ways the same thing, but it's called a monoculture. This is a huge farm. Who knows? I think it's in Central California, but it could be in Indiana as well. But here they are growing sunflowers because there's oil that we get from sunflowers. So farmers like to have what we call monocultures. But monocultures have problems too. So let's go to the next. That's one thing you might discuss with your teachers. Okay, let's go to the next slide. And the honeybees have a lot of enemies, and I'd like to tell you what some of them are, who they are. Here is an example of why a honeybee needs to have their hive inside the tree. You can see the hole right there. That's used to be where their hive was, but it wasn't big enough. So then they started one out here. This is not a good idea because animals can come and rob the comb. Inside this comb is delicious honey and also the larva. And this hawk is going to steal and eat that, take it back to its nest. Here we have a yellow jacket, which in California, they're very dangerous. If I have my hive open too long, then these yellow jackets will come over and they will steal the larvae and eat them. Here's a dragonfly. I told you they love to eat the bees, and yes, they catch them in flight. It's amazing. Oh my goodness, who is waiting outside the front door at nighttime for the honeybees? They knock on the doors, and yes, the bees come and say, "Who's there?" That's not a good thing to do because they will just eat those bees right up. This is another kind of an enemy of the bees, but sometimes they rob each other's hives. So what we do as beekeepers, we cover them up with a wet sheet and we keep it wet so the bees think that it's nighttime. Here's one of the worst enemies of the honeybee. It is called the varroa mite, and it's like a tick. And you know what a tick does to you. When it comes in and bites you, it can also put in all kinds of um, terrible diseases, like Lyme's disease. Well, mites have diseases that honeybees get. Here's an example of one disease. It's called the deformed wing disease. And you know, if a bee can't fly, there's not too much good they can do for the hive. So we try to, as beekeepers, get rid of the varroa mites. So I'm going to give you one little hint about this, and then you'll have to talk with your teachers about what strategies do beekeepers use to get rid of the varroa mite. But this mite, the female has to lay her eggs inside the comb of the honeybee and inside where the eggs are in the larva. If the varroa mite did not have the larva of the honeybee, it would die off. It would become extinct. So there's my question for you, is my challenge. What can you suggest to me to get rid of the varroa mite? Let's talk a little bit about wax making. Wax making takes a lot of energy. And so by making it into, if we look over here, this is a hexagonal cell as opposed to circles. You can see this wasted space here. And you can see how they have to actually build two walls, one for this circle and one for this circle. But here they share a wall, so there's less wax needed. This is the beautiful comb on which there will be honey, and here's where the babies are. Wax making is one of the things I love about beekeeping because, first of all, I love collecting the honey and giving it to my friends, but I make a lot of candles, which I think are fun to do. Now, here's some other artwork that I've collected. This is a quilt from Indiana, from my family in Indiana. And look at all the hexagonal cells. And here's a lounge in an office building, and they have used hexagonal cells too. So it's architecturally. I hope you will go out and look for hexagonal cells in nature. They're all over the place. Here's a stepping stone with flowers and a honeybee. So that's kind of fun to have in your garden. And here is some of my artwork. Well, that's the end of my presentation, but let me just end by saying we live in an ecosystem of plants and animals. We all have jobs that we have to do to make our ecosystem healthy, safe, and fun. No matter what you do, no matter how old you are, start today to become a good member of the ecosystem. And one thing you can do is to plant a pollinator garden for all pollinators, like honeybees, butterflies, and hummingbirds. So I'm going to stop this share, and hopefully all of you are still awake and thinking about the presentation. Mr. Thorpe, are you there?
Yeah, we'll see. Does anyone have any questions that they want to ask? All right, because I'm coming up here so she can see you and hear you. We have a couple of questions if you're okay with that.
Okay.
Ask your question.
Oh, good.
All right, ask your question.
How long do honeybees live?
Very good question. They live actually different lengths of time. The queen lives about a year or 2 years. After 2 years, she doesn't become as good of a queen, and we need good queens. The drones, the males, can live up to a year. And the worker bees, they live about 3 months. They work so hard by flying out to get the pollen that then they die. So different times, but every year there is like a new population that we deal with. Another question?
What happens when the queen dies?
Well, what happens when the queen dies? Very good question. Obviously, they have to make another queen. So what they do is they find a female egg. So it has to be a girl egg. And they feed that royal jelly to that egg, and eventually it becomes the next queen. Now, sometimes the queen dies in the hive and the bees have not prepared for it. There are all kinds of things. Like, for instance, a beekeeper could go into the hive and accidentally kill the queen. So then they will hopefully find a girl egg and make it into another queen. One of the things, if you don't have a good queen, I can go into a different hive and get some eggs, girl eggs from that hive, and bring them over to the hive that has no queen and put them in there, and then they will make a queen from that egg. Other questions? Those are great questions.
Mr. Reagan, does your class have any questions for us?
Okay.
Do the bees have maps in the hives?
Do the bees have what?
Maps.
Maps?
Yeah,
Oh, naps. You mean like taking a little nap? Or you mean geographical maps? Okay, I'll hope that you're asking for both of them. So, yes, bees do take naps. And one of the things that happens early in the morning when the bees get started and they feel the sun is coming up, they go and they shake the bees who are napping. They just go up to them and shake them like this. Wake up, we have to get to work. Of course, bees don't talk in the same way we talk, but that is what they're saying. We have to go
Oh,
out
so just
and we
like
have to work.
parents wake their kids up, right?
Now, after they get going, of course, then in the evening when it gets colder, they do take naps. They huddle together in their cluster and they create warmth because the temperature inside the hive has to be warm enough to keep the larva warm. And that is about 94 degrees. You know, that temperature is very similar to our own bodies. We have to have a certain temperature. Now, when our bodies have that temperature, it's around the heart area where you have the temperature, but like your fingers are cold. Well, it's the same way in a beehive. The cluster on the inside where the larvae are has to be 94 degrees. But on the edges of the round ball, the cluster where the honeybees live, that could be a lot less. So those bees have to continually circle round to the center of the hive to create heat. Now, as far as maps go, I don't know if you meant geographical maps, but when they go out, they have actually five eyes. And they have two eyes on the left and right side of the head, but they also have three eyes up here. Now, think about those three eyes. Those are the 3 points of a geographical map. So one eye can figure out where the sun is, one where the hive is, and one where the flowers are. So when the bees go out to find the flowers, the scout bees come back and they measure exactly all those things. How far away is the hive? What angle is it away from the sun? And so as the sun comes up and changes that angle, they have to also change that information to the other bees in the hive. Okay, Mr. Thorpe, I'm sure that we're getting close to time's up.
How long have you been beekeeping?
Oh, good question. I've been beekeeping about 15 years, and I sure have learned a lot. And every time I go into my beehive, I learn more. And what I'm learning now is that although science is very exact, Beekeeping is always different. It's like being a teacher in a school. Every student is different, and a good teacher has to be a teacher for all students. So that's what I have to be for my beekeepers. I'm like a teacher. I listen to my bees and I help them to be a healthy hive.
Mr. Reagan, we'll let your class take the last question. You guys have one more question for us?
How long do mites stay on a bee before it dies?
Oh, I just love this question, and I can tell that you're thinking about what we can do as beekeepers to get rid of those mites. Oh, they are a problem. So, how long do they live? They live actually a long time, but they die if the wax that's sealing the cell of the larva, if that wax is opened and oxygen goes in, it actually can kill that mite. So one of the behaviors that the honeybees have evolved and changed to is that they make little holes in the wax. And then the mite dies, and then they cover it back up again so that the larva can continue to live. So yeah, they live a long time, and when they come out, they can actually fly on the bodies. They can stick to the bodies. They don't fly, by the way. They have no wings, but they can stick to the body of the honeybee. And when the honeybee goes out to forage at a flower, they can jump from one honeybee to the other flower, and that's how they get to other hives. So that ability is one of our problems. I hope I've answered all of your questions. I love talking to you. I feel so honored that I was asked to come, even though it's early in the morning for me. But I sure love teaching, and I have my hope in all of you that you'll make a good pollinator garden next for your next sessions of classes.
Awesome. Well, let's give Dr. Veirling a big round of applause, everybody.
It's